Hey guys, I hope you enjoyed last week's lesson on different ways of interpreting the mean, where we looked about how our understanding or our assumptions we make based on one number can lead us to false conclusions. This week, I'm really interested in seeing your preliminary work to see how many of you guessed the topic that would help us explain the battle between uh, Daniel Kahneman and the flight instructors. The mathematical concept that's going to solve that for us is regression to the mean. Hopefully, you'll find this interesting. It does apply a lot to the real world. There's a lot of times where we see a cause and effect, and that cause and effect, we're trained to think that scientifically, when we see something and we see an effect, that the cause is, well, in fact, causing the effect. Sometimes we're assuming that it's causing the effect, and there's something else going on, which leads to false pattern recognition. And that's what this lesson will be about. All right, so I wanted to start off with a part of one of my favorite poems, if not my favorite poem, the poem "If" by Rudyard Kipling, who probably is a pretty terrible human being, particularly by today's standards, but the poem is really nice. So the line that I wanted to focus on: if you can meet with your triumph and disaster, and treat those two impostors just the same. We'll revisit this at the end of the lesson, but I want you to kind of think about how these words as we go through this lesson. Okay, so our debate. We have the actual Kahneman over here. And Kahneman was telling the flight instructors that, look, we've been studying this stuff in psychology all of the time for decades, for years, and we know that rewarding positive behavior is very, very effective in behavior change, and punishing negative behavior is not. It just doesn't work when we do these studies. And here we have the flight instructor from Top Gun standing in for the Israeli Air Force, basically calling him out and saying, I'm calling bull on this. When my instructors, I'm sorry, when my flight cadets do something well, when they perform a maneuver well, I compliment them. The next time they get worse. And if they do terrible and I tear into them, the next time they get better. So, how is this possible? Like, you're telling me that positive behavior works, negative doesn't, and I'm telling you from my experience, positive reinforcement didn't work and negative did. So we want to consider, how is this possible? Because it's true, Kahneman is right, but the instructor's observations are also both correct, and it seems like they are in opposition to each other, but they aren't, because of this concept called regression to the mean. What regression to the mean states is in any series of events, sorry, catch my breath here. In any series of random events, an extraordinary event is most likely followed due purely to chance, not to complimenting or yelling, but due purely to chance, by an ordinary one. And just think about this. If most things are around the average and you happen to have a really, really good day, the chances are your next day is probably going to be closer to average. So let's look at this in the context of the Kahneman and the Air Force. So if you're an Air Force instructor, a flight instructor, when do you praise your pilots? Well, you praise them when they perform very, very well, exceptionally well. Or maybe we could say you praise them when they perform extraordinarily well. So your pilot does something really, really good. They've done really, really well that day, above their normal performance, and you compliment them. When do you yell at your pilots? When are you screaming at them and tearing them apart? Well, you're doing that when they've underperformed, when they perform worse than they normally do, or what you could call extraordinarily poorly. The worse they perform, probably the harder you're going to yell at them and scream at them. This leads to a false pattern recognition. The pattern is, when I praise them, they get worse. When I yell at them, they get better. Right? So that is definitely a pattern, but the conclusion we draw from it, or the conclusion that the Air Force instructors drew from it, that yelling works and praise doesn't work, was the wrong conclusion. And this should bother us a little. Like, it seems so logical. I yell, they get better. I praise them, they get worse. So it seems like we've got this pattern. We understand it. We have cracked the code. From now on, I'm just going to scream at people to try to get them better. And I'm sure you guys have had teachers who think that that's an effective strategy. Hopefully, I don't sound like I make that list. So let's take a look at what was actually going on here. In reality, You praise them when they did extraordinarily well. Whether you praise them or not, the regression to the mean tells us if they did extraordinarily well, it's most likely, due to pure chance, their next performance is going to be ordinary. So whether you praise them or not, if somebody did extraordinarily well, next time bet on them being closer to average. And it looks like they got worse, but really they're just performing at their average, and the time they did really, really well was the outlier. So again, what's really going on here? What's really going on here is we compliment people when they do well, we yell at them when they do poor, and it seems effective because the behavior changes in the right direction when we yell and in the wrong direction when we praise. Um, but in reality, if somebody does really, really well, they're always going to drop closer to average on their next performance, or usually going to drop closer to average in their next performance. And when somebody does really, really poorly, they're usually going to get better on their next performance. So I hope that you see what's going on here is regression to the mean is really explaining why the pilots are getting better or worse. And it has literally nothing to do with yelling or praising in this situation. So how often do we make this mistake where we have the false pattern recognition making us think that we've figured out why something's happening, and in reality, the thing behind it is really just regression to the mean? Well, unfortunately, this happens often. So that should worry us because what's it cost us if it happens that often? Well, it can cost us millions of dollars in pointless actions, lots of wasted time doing things that don't actually matter. And in the case of the last situation, it could really cause some emotional harm. You'd like to think in the Air Force everyone's tough and can take it, but as I mentioned, teachers think that strategy works as well. So let's look at some examples of where this also takes place in the real world. We'll start off with UK traffic accidents. So there was a lot of accidents in the United Kingdom, and logical question to ask is, what can we do about this? How can we reduce the car accidents, particularly at intersections where they seemed pretty high? Okay. What the law enforcement of the country came up with was like, all right, let's look at the intersections. We'll see where the accidents are happening the most often. So they looked over the recent records and they saw, I don't know the exact number, but they saw a few intersections where there was high levels of accidents. So they said, all right, well, we want to make those intersections safer as they seem to be the biggest problems. Let's install traffic cameras. Let's install traffic cameras in those locations. If we install the traffic cameras, the idea is people will be worried about getting their tickets for going through red lights or for speeding, so they'll drive safer. And if people are driving safer due to those fears, they will, be less likely to get in accidents. Well, did it work? It did. All of the intersections where the traffic cameras were installed, less accidents occurred in the months following the installation of the cameras than before. All right, this is great. So it seems like we've cracked the code. There was lots of accidents. We put up cameras. There was a lot less accidents. Should we put up more traffic cameras? Well, it's kind of hard to say. You could see where the evidence looks like we have a cause and effect. The cause, the action, we put up the cameras. The effect, there's less traffic accidents. However, it's really likely to have a lot to do with regression to the mean, particularly if they were just looking at places that had spikes in car accidents. So places that over the previous months before the camera was going up had a spike in car accidents. Those were extraordinary. They were outside of the normal. They were extraordinary measures. And because of that, whether we put the cameras up or not, the traffic accidents were likely to go down in the following months. So I hope that makes sense to you. It doesn't mean we can't say that the traffic camera didn't have any effect. It very likely could have had effect. But we also have to consider the fact that without those traffic cameras, the car accidents were likely to go down if they were extraordinary events anyways. Okay, taking another look at an example here. So the example we're going to look at now is the SAT scores. It turns out in 1987, 25 test-anxious U.S. students had performed unexpectedly poorly. So extremely poorly, extraordinarily poorly, worse than had been expected on the SAT exam. And so they were like, all right, these students were anxious. Maybe if we give them the hypertension drug propranolol, I don't know how to say that, and retested them. Like, we'll see if that drug has any effect on their score. Well, did it? Here's the New York Times headlines after that study. A drug tested to control high blood pressure has dramatically improved scholastic aptitude test scores for students suffering from unusually severe anxiety. All right, well, the headline says this drug works, right? The headline's basically making us believe that the drug has, well, I don't know that we want to say the drug's improved the scores, but the drug has allowed the students to improve their scores. In fact, if we look at the actual numbers, which is always important to do with these studies, it turns out these students did improve their scores on average by 130 points. And it's worth noting that the SATs at that time were scored between 400 and 1600. So an improvement of 130 points is very significant in SAT scores. We're talking drastically different types of colleges you can be looking at. All right, so all of this sounds really good, and it sounds like we've got this magical pill that we can give to students who have anxiety about tests, and all of a sudden they'll perform, more as they should. Well, let's also take a look at what happens when non-anxious students who don't take drugs retest. Well, they retest by 40 points when they retake it, on average. Some obviously make that 130, some get much better. But in general, when students take the SATs a second time, their scores improve by 40 points. So again, 130 points average versus 40 points average, you might sound like, well, I don't know, this drug still sounds like it's working. Before we consider that, we should remember how this studied group was chosen. They were students who had performed unexpectedly poorly. So it wasn't just your average SAT student who got a second chance. It was the students who we thought should do really well, but didn't. In other words, they performed extraordinarily below where their average was. Well, the law of regression to the mean says if they're performing so far below their average, such an extreme event, it's more likely if they were retested without any drugs or anything, that their next test score would be much closer to their average. So when I look at the difference between the 130 and the 40 points, I'm thinking, well, if they performed that unexpectedly poorly that we considered giving them a drug, they might have been about 130 points below where it was expected that they should have been. And again, we have a situation where it looks like we have an effective treatment for something, but it is likely just regression to the mean. And we don't necessarily want to be pumping people through full of drugs for an effect that is granted just by the fact that they took a test the second time, having nothing to do with the drug. I should note here, I think this is on the previous slide as well, a lot of this information comes from the book Math of Life and Death in 7 Mathematical Principles That Shape Our Lives by Kit Yates. It's a fantastic read. I highly suggest it. You don't have to be well-versed in mathematics to understand it. It's just cool examples like this. Okay, so some of you might be thinking, could the test scores be improving because of the placebo effect? I'm really glad you asked that. For those of you who aren't aware of what the placebo effect is, you can read the definition I have here. I'll come back to that in a second. But essentially, we think of it as if you believe you're taking something that will make you do better on a test, that alone can cause you to do better on the test. I took this definition here from the Oxford English Dictionary. It says, the placebo effect is a beneficial effect produced by a placebo drug or treatment which cannot be attributed to the properties of the placebo itself, and therefore must be due to the patient's belief in that treatment. Ugh. I don't like the last line of that at all. So before we come back, and we'll talk about how much the last line of this, it must be due to the patient's belief in the treatment. They're telling us that, you could be taking a sugar pill, which has no effect on your IQ, but because you believe it does, it'll actually improve your IQ. And I have some questions about this. And I had been taught the placebo effect back when I was a freshman or sophomore in high school, and I thought it was amazing. It was so cool, but there might be more going on. So before we answer whether the placebo effect could be making a difference in that study of SAT scores, let's take a look at one more example. And then from there, we'll talk about the role of the placebo effect. So, can bee stings cure joint pain? This actually is something that is commonly promoted. So let's see. Imagine, for example, recruiting a large number of people suffering from joint pain and asking them to sit while you sting them with live bees. This might sound pretty absurd to you guys, but it's a genuine, quote unquote, genuine alternative therapy known as acupuncture. It's recently been made pretty famous because it's been promoted by Gwyneth Paltrow on her Goop Lifestyle website. So now imagine that we do this study where we take these people with joint pain and we stick them with bees, and miraculously, some of the sufferers' joint pain goes away. On average, here we go back with that average term from the last lesson, on average, they start to feel better after the therapy. Can we conclude that acupuncture is effective therapy for joint pain? So again, people are suffering from joint pain. We sting them in the arm with live bees, and on average, they feel better afterwards. Is that enough evidence for us to say that acupuncture is an effective therapy for joint pain? Well, this might not be a surprise to you, but probably not. So one thing we should know about joint pain is people who suffer from joint pain, it fluctuates over time. Some days are better than worse. Some weeks are better than worse than others. Some months are better or worse than others. So it fluctuates over time. Next thing we want to consider is who's signing up for this treatment where they, are being volunteered to have live bees sting them in their arm. You're probably not mildly suffering from joint pain. You're probably not like, I don't know, once every year or so, my knee's a little stiff. You're probably on that side where, man, things are really bad right now and nothing else seems to be working. What else can I try? So that means to me, you're in a lot of pain, you're probably at an extreme, and you've probably been in that extreme for a decent period of time. Not just like a one-day thing. Well, this is probably just regression to the mean then. You were in an extraordinary level. You were outside of your ordinary, so you decided you'd get stuck by bees, and then you started feeling better. The point being, if you hadn't been stung by bees and you are at a low, there's generally only one direction to move up from an absolute low, and that's to get better. So again, this is an exaggerated case of it, but we see a situation where it looks like there might be evidence that bee stings are helpful, but unless this is tested in a really controlled way where you can rule out that, it's likely that people are just starting to feel better on average, because on average, when people are feeling bad, they start feeling better after a certain period of time. For what it's worth, they have tried testing this stuff in much more controlled settings. And acupuncture has been, claimed by alternative health to cure lots of things. At this point, there is no scientific evidence that supports acupuncture treats any disorders. Okay, so back to the placebo effect, both in the testing and in the bee kit. Maybe the people got better from the hypertension drug because they believed the hypertension drug would help them on the test. Maybe people got better from the bee stings because they believed the bee stings made them better. And perhaps, there's probably some element of that role. But a more significant reason in both of those is probably regression to the mean. The only way to determine which is more significant, people believing that they are being treated, the placebo effect, or regression to mean, if we're trying to compare them, the only way to do it is to have a dummy treatment given to one group and no treatment at all given to another. These types of trials are often considered unethical, essentially because you are not treating anyone for anything, but you're telling them you are in one group. So there's no chance of, trying to help people get better in that situation. So because of that, it's not encouraged that these studies are done often. But enough studies have been done in the past to indicate that the majority of the so-called placebo effect is actually just the result of regression to the mean. I remember reading that and it kind of blowing my mind, because I've known of the placebo effect forever and it sounds so cool. I want to believe that the mind can just make you better. But the regression to the mean just makes so much sense. So it's very logical, and it's something that I can see happening. So when we think about the placebo effect, I'm not telling you there's not a role of it. I'm just telling you that a lot of it might just be regression to the mean. And again, it's really hard in any particular study um, to decipher which one it is, or how much it's the placebo effect and how much it's regression to the mean. All right. What do I have here? Could test scores be improving as an example of the placebo effect? First, for those of you who are, oh, I see what I did. I put in a slide to go back to the definition. All right, here's what I said. I said I wanted to revisit this definition. First, for those of you who are not aware, the placebo effect is a beneficial effect by a placebo drug which cannot be attributed to the properties of the placebo itself. Okay, I have no problem with that part. That part of the definition is fine. It's this last sentence where it says, and therefore must be due to the patient's belief in the treatment. Maybe we should amend that last line to say it could be due to regression to the mean and slightly due to the patient's belief, or some mixture of regression to the mean and patient's belief. But the Oxford Dictionary has not caught up with the science here. And by the way, the science of regression to the mean is very old. It's Galton, I think, was the first person who discovered it. And I don't know the century off the top of my head. I want to say it was the 17th century, but I'm not positive. So back to the poem. The poem "If" by Rudyard Kipling. You can meet with your if you can meet with your triumphs and disasters and treat those as those two imposters just the same. So again, I love this line, and I think it relates to regression to the mean. We are average. We have our baselines. Sometimes we have really, really great days and things go all of our way. And we can't get upset when that doesn't happen and we return to normal. It's not a failing for us. It's just that was an extraordinary event. And the same is true for when we have those terrible, terrible days and everything seems to go wrong. That's if that is our extraordinary event outside of the means. So you had a bad day, you can bet on the next day being a lot better because we tend to regress to the mean. All right, that's the end of this slideshow on regression to the mean. Again, I hope you guys found it interesting how we can make what seems like logical conclusions and they could still be false because there's something hiding behind them. There's a pattern behind them that we know from statistics. All right, guys, hope you enjoyed. Hope you're staying safe and healthy. Take care. Bye.